Hubble Space Telescope embarks on its journey into the vast expanse of space, bringing with it the promise of a new era in astronomy. Launched in April of 1990, its mission was clear to capture images and gather data that could reveal more about the universe than any previous telescope had been able to achieve. The telescope was placed into orbit around Earth, free from the distortion caused by the atmosphere, providing an unparalleled view of distant galaxies, nebulae, and other celestial objects. Hubble's design an optical telescope capable of capturing clear images in the ultraviolet, visible and infrared spectra made it a revolutionary tool for astronomers. Unlike ground-based observatories, which are often plagued by the blurring effects of Earth's atmosphere, Hubble's vantage point in space allowed it to observe the universe with exceptional clarity, bringing into focus regions of space previously unseen by the human eye. As Hubble's first images began to stream back to Earth, it quickly became apparent that its capabilities far exceeded expectations. The sharpness of the images, the ability to peer deep into the cosmos, and the telescope's capacity to observe objects that were previously too faint or distant to study, all marked a new chapter in our understanding of the universe. Early on, Hubble began its mission of exploring the far reaches of space, capturing views of the most distant galaxies and unveiling parts of the universe that had been hidden from view. Its images, sharp and detailed, were more than just beautiful pictures. They were windows into the past, revealing light from distant stars and galaxies that had travelled billions of years to reach Earth. The journey of this telescope and the discoveries that it would enable was just beginning, and already it had begun to reshape our understanding of the cosmos. The Hubble Space Telescope was designed to capture a wide variety of astronomical phenomena, but one of its most important early tasks was to focus on the deepest, most distant regions of space. The goal was to peer as far back in time as possible to observe galaxies and stars as they were when the universe was much younger. In order to achieve this, the telescope needed to look deep into a small, seemingly empty patch of the sky. The decision to focus on this area known as the Hubble Deep Field was made in 1995. At first glance, this part of the sky appeared to contain very few stars or galaxies. However, this patch of space was chosen precisely because of its apparent emptiness. If there were galaxies in that region, they would be distant and faint, providing a unique opportunity to look back in time to the earliest moments of the universe's existence. Over the course of 10 days, Hubble focused on this small region of the sky, collecting light from some of the most distant galaxies known to humankind. The exposure was long, allowing the telescope to gather as much light as possible from the faintest objects. The result was a groundbreaking image, a deep revealing view of the universe's distant past. The Hubble Deep Field image revealed thousands of galaxies, many of them in various stages of development, some only a few 100 million years old. The image provided a snapshot of the universe as it was billions of years ago, allowing astronomers to study galaxies that had formed when the universe itself was still young. The Hubble Deep Field image, once released, transformed the way scientists understood the size and complexity of the universe. What had once been thought to be a nearly empty space turned out to be a treasure trove of information about the early universe. The image captured galaxies that were so far away that their light had taken billions of years to reach Earth. The light from these galaxies was also a glimpse into the past, revealing what these galaxies looked like when the universe was still in its infancy. The galaxies captured in the deep field were not the mature spiral galaxies we see today. Many of them were smaller, irregularly shaped, and contained only the simplest elements such as hydrogen and helium. These were the building blocks of the more complex galaxies that would later emerge, and their study provided scientists with critical insights into how galaxies form and evolve over time. The image also provided the first evidence of the vastness of the universe. The Hubble Deep Field revealed not just a handful of galaxies, but thousands, each one potentially harboring billions of stars. It became clear that the universe, far from being a small finite place, was unimaginably vast, filled with billions of galaxies stretching across incomprehensible distances. The number of galaxies seen in the deep field suggested that the universe contained far more than previously thought. It was a humbling reminder of just how small Earth and our solar system are in the grand scheme of the cosmos. The deep field was not just a single snapshot. It was a symbol of the vastness of space, of the untold number of galaxies, stars and worlds waiting to be discovered. In addition to revealing the immense scale of the universe, the Hubble Deep Field image also helped scientists understand the timeline of the cosmos. The galaxies in the image were not simply far away. They were also from different points in the universe's history. The farther back in time we look, the less evolved the galaxies appear. Some of the galaxies in the deep field image were still in the early stages of formation, while others were just beginning to form the structures that would eventually evolve into the galaxies we see today. This snapshot provided a rare opportunity to study the universe as it was billions of years ago, allowing scientists to trace the evolution of galaxies from their birth to their mature forms. The deep field gave us a look into the past, but it also raised questions about how the universe evolved and the role that galaxies, stars, and the cosmic forces shaping them played in this ongoing transformation. Through the Hubble Deep Field, astronomers began to probe deeper into the mysteries of the universe's formation. The galaxies revealed in this image, many of them faint and distant, were some of the oldest objects ever observed. The study of their properties, their shapes, sizes, colours, and redshifts provided crucial data about the conditions that existed when the universe was in its infancy. For example, scientists were able to determine the rate at which galaxies were forming new stars and how the first elements were synthesized. This allowed astronomers to better understand the processes that took place in the early universe, leading to the formation of the complex structures we see today. Even as new questions arose, the image itself became a landmark achievement in astronomy, a testament to Hubble's power and its ability to unveil the universe's deepest secrets. The Hubble Deep Field image changed the way astronomers approach the study of the universe. It shifted the focus from nearby well-understood galaxies to the more distant, mysterious ones that formed the early universe. The discoveries made from this image led to new questions and new avenues of research, some of which continue to be explored today. The image provided the first direct evidence of the universe's vastness, complexity, and evolution, offering an unprecedented glimpse into the distant past of our universe. By looking back in time, Hubble opened up new possibilities for understanding the origins of galaxies, the formation of stars, and the fundamental processes that govern the cosmos. As the Hubble Space Telescope continued its mission, its role in expanding our understanding of the universe grew clearer with each passing year. The image produced by the Hubble Deep Field had forever changed how astronomers viewed the vastness of space and the evolution of galaxies. The telescope's ability to peer into the most distant corners of the cosmos and capture light that had travelled for billions of years enabled scientists to witness the universe in its infancy. The time frame revealed by the Deep Field image represented a crucial window into the early stages of galaxy formation, a period when the universe was only a fraction of its current age. The galaxies seen in the Deep Field were not static. They were living, evolving systems just beginning to take shape in the aftermath of the Big Bang. They were the building blocks of the universe we observe today, yet they existed at a time when the cosmos was still very young. Looking at these galaxies through the lens of the Deep Field was like looking at the universe through a time machine. The farther away a galaxy is, the older its light is. Light travels at a fixed speed, so when we observe distant objects in the universe, we are seeing them as they were in the past. The galaxies captured in the Deep Field image were all seen as they were billions of years ago, long before our Sun, and even before the Earth had formed. This fact alone was a profound realization. The idea that the light we were seeing had taken that long to reach us, that we were looking at distant events in the history of the universe, was awe-inspiring. It was as though we were witnessing the building blocks of the cosmos frozen in time, waiting for us to explore their story. The Hubble Deep Field also raised important questions about the nature of galaxy formation and the evolution of the universe itself. One of the most significant discoveries from the Deep Field was the realization that galaxies were not static, unchanging objects, but instead were in a constant state of flux. The galaxies captured in the Deep Field were of various sizes, shapes, and stages of development. Some were compact and irregular in shape, while others were already beginning to show the structure of more mature spiral galaxies. This diversity was a reminder that the universe's evolution is not a simple linear process, but one marked by complexity and change. The varying stages of galaxy formation visible in the deep field suggested that galaxies formed in different ways and under different conditions, influenced by factors such as gravity, the distribution of matter, and the age of the universe itself. The discovery of so many galaxies, each one a potential seed of a future cosmic structure, expanded our understanding of the early universe and the processes that led to the formation of stars, galaxies, and larger cosmic structures. It revealed that the universe's evolution was far more intricate and diverse than previously imagined. The galaxies in the deep field were not isolated from one another, but were part of a larger interconnected system of structures, each one playing a role in the universe's grand design. The image not only showcased the diversity of galaxies, but also provided clues about how these galaxies interacted with each other, how they grew, and how they eventually coalesced into the massive spiral, elliptical, and irregular galaxies that dominate the universe today. Hubble's deep observations also illuminated the role of dark matter, an invisible substance that, while not directly observable, influences the movement of galaxies. The deep field image, in conjunction with other observations, allowed scientists to infer the presence of dark matter in the galaxies, revealing that the mass of visible matter in galaxies is only a fraction of their total mass. Dark matter, it seemed, played a key role in shaping the evolution of galaxies by providing the necessary gravitational pull to hold them together. Despite its invisible nature, dark matter was found to have a significant impact on the development of galaxies, playing an essential role in the way the universe took shape. This connection between galaxies and dark matter deepened our understanding of the forces at play in the universe's evolution. Without dark matter, galaxies would not have formed in the way they did, and their structure would be vastly different. This realization led to further investigations into the nature of dark matter, a mystery that continues to puzzle astronomers. While the exact properties of dark matter remain unknown, its influence on the structure and dynamics of the universe is undeniable. The Hubble Deep Field, through its detailed observations of distant galaxies, helped lay the groundwork for the ongoing search to understand this elusive force. The discoveries made from the Hubble Deep Field image also had profound implications for the study of cosmology, the branch of astronomy that deals with the origin, evolution, and eventual fate of the universe. By revealing the universe's state in its early years, the Deep Field provided critical information about the universe's age, its rate of expansion, and its evolution over time. The data obtained from this image, combined with other observations made by Hubble and ground-based telescopes, allowed scientists to refine models of the universe's history. These models helped clarify our understanding of the Big Bang, the cosmic inflation that occurred shortly after the Big Bang, and the subsequent cooling and expansion that led to the formation of galaxies and other structures. Hubble's observations provided critical insights into the universe's timeline and how it has evolved from a hot, dense state to the vast, complex system we observe today. In addition to revealing the universe's early history, the Hubble Deep Field image also opened up new possibilities for studying the universe's distant future. By observing galaxies at various stages of development, scientists were able to piece together a better understanding of the forces that shape galaxies over time. The image provided clues about how galaxies grow and evolve, how they interact with each other, and how they may eventually merge or be destroyed. These insights into the life cycle of galaxies have profound implications for understanding the fate of the universe. As galaxies continue to evolve and expand, their interactions will shape the future of the cosmos, and understanding these processes is crucial for predicting the universe's long-term future. The Hubble Deep Field was not just an image, it was a gateway to understanding the universe itself. It provided astronomers with an unprecedented view of the distant past and revealed the richness and complexity of the cosmos. In many ways, the image marked a turning point in our understanding of the universe's history and evolution. It transformed the way we think about the cosmos, providing a deeper appreciation for the vastness of space and the intricate processes that govern its existence. The Hubble Deep Field, by offering a glimpse into the universe's distant past, allowed us to witness the birth of galaxies and to glimpse the fundamental forces that shape the cosmos as we know it. The Hubble Deep Field image, a long exposure photograph taken by the Hubble Space Telescope, quickly became one of the most iconic and significant images in the history of astronomy. Its impact on our understanding of the universe cannot be overstated. The image, which captured a tiny patch of sky no larger than a grain of sand held at arm's length, revealed thousands of galaxies, each one potentially containing billions of stars. At the time of its release in 1995, this image marked a profound leap in our ability to observe the distant reaches of space-unveiling galaxies that were up to 12 billion light-years away. What we were seeing was not just a snapshot of the present, but a glimpse into the universe's past, a time when these galaxies were still in their infancy. This image forever altered our perception of the universe. The sheer number of galaxies, many of which were previously unseen, showed just how vast and rich the cosmos truly is. More than just a collection of distant stars, the Deep Field image revealed a dynamic, evolving universe filled with galaxies at different stages of development. Some galaxies were already mature, resembling the familiar spiral and elliptical shapes we see in the nearby universe, while others were in their early stages, smaller and more irregular in shape. The diversity of these galaxies was astounding, offering astronomers an invaluable look at the variety of galactic structures that exist. In addition to showing the vastness of the universe, the Hubble Deep Field provided evidence of the age and evolution of galaxies. The light from these galaxies had travelled for billions of years to reach Earth, meaning that the galaxies we were observing were not just distant but ancient. Many of them existed at a time when the universe was still relatively young, just a fraction of its current age. This allowed scientists to study galaxies as they appeared in their early formative stages. For example, some of the galaxies in the Deep Field image showed signs of ongoing star formation, with regions of intense activity where new stars were being born. Others appeared to have already formed their basic structure, but still lack the full range of stellar populations found in more mature galaxies. This view into the past was not just a curiosity, it was a breakthrough in our understanding of how galaxies evolve over time. By observing these distant galaxies, scientists were able to gain insights into the processes that govern galaxy formation and growth. The Hubble Deep Field also revealed that galaxies grow and evolve in a variety of ways, influenced by their environment, their interactions with other galaxies, and the fundamental forces of the universe. Some galaxies appeared to be isolated, while others were in the process of merging with neighbouring galaxies, a process that is thought to play a significant role in galaxy evolution. The Hubble Deep Field also gave scientists a glimpse into the early universe's composition. The galaxies in the image were not composed solely of the familiar elements hydrogen, helium, and oxygen that make up our own galaxy. Instead, many of them were in the process of forming heavier elements such as carbon and iron through the process of nuclear fusion. These elements created in the hearts of stars are the building blocks for planets, and by studying these early galaxies, scientists were able to learn about the formation of elements that would later be crucial for the development of life. One of the most profound aspects of the Hubble Deep Field image was its demonstration of just how little we truly knew about the universe. Prior to the image's release, astronomers had only been able to observe galaxies in the relatively nearby regions of the universe. The Deep Field provided a look into a part of the sky that had previously been thought to be empty, showing that even in the emptiest seeming areas of space, the universe was teeming with galaxies. It was a reminder of how much more there was to discover, how much more there was to understand. It was a humbling realization, one that made us aware of the limitations of our knowledge and the vast, largely unexplored expanse of the cosmos. The Hubble Deep Field also raised important questions about the structure and origins of the universe. The image provided strong evidence that galaxies were not randomly distributed throughout space, but instead formed a vast interconnected web. This web, known as the cosmic web, consists of galaxies, clusters of galaxies, and vast voids of empty space. The Deep Field showed that galaxies are not isolated, but instead a part of a larger structure, one shaped by gravity, and the expansion of the universe. By studying the distribution of galaxies in the deep field and comparing it with other regions of the universe, scientists were able to learn more about the forces that govern the formation of these large-scale structures. This information has proven to be crucial in understanding the role of dark matter and dark energy, the two mysterious substances that make up most of the universe's mass and energy. In addition to its scientific significance, the Hubble Deep Field also had a profound impact on the public's perception of the universe. The image, with its breathtaking beauty and vast scale, captured the imagination of millions around the world. It made the universe seem more tangible, more real, and more accessible to the general public. It was no longer just a collection of distant stars and galaxies. These were real places with their own histories, processes, and mysteries. The deep field image became a symbol of humanity's quest for knowledge and our desire to understand the cosmos. It reminded us of the wonder and awe that space inspires and the potential for discovery that lies in the stars. The Hubble Deep Field also helped to solidify the importance of space-based astronomy. While ground-based telescopes had provided invaluable insights into the universe, they were limited by the distortion caused by Earth's atmosphere. Hubble's position above the atmosphere allowed it to capture images with unparalleled clarity, providing a level of detail that had never been seen before. The success of the deep field image demonstrated the power of space-based telescopes and their ability to revolutionize our understanding of the cosmos. The deep field was just the beginning. Hubble would go on to capture countless other images, each one adding to our growing knowledge of the universe and the processes that shape it. In the years following the release of the Hubble Deep Field, astronomers would continue to use the telescope to explore ever deeper regions of space. The deep field itself would be revisited with additional observations capturing even more distant galaxies. Hubble's legacy in many ways began with that one image. It showed us the universe in a way we had never seen it before, and it opened up a world of possibilities for future discoveries. The Hubble Deep Field is a reminder that the universe is far more complex, diverse, and beautiful than we could ever have imagined. The Hubble Deep Field was not just an image, but a profound shift in our understanding of the universe. It offered more than a glimpse into the distant past. It became a tool for measuring the cosmos itself, marking a significant milestone in the study of cosmology. The process of observing the universe in such depth allowed astronomers to see not only how galaxies had evolved, but also to estimate the age of the universe with greater precision. The light from these galaxies, having travelled for billions of years to reach Earth, brought with it a message from a time when the universe was only a fraction of its current age. This deep view into space provided a means of studying the early stages of galaxy formation, offering scientists the rare chance to look at the universe as it was shortly after the Big Bang. The key insight from the Hubble Deep Field was that galaxies are not randomly scattered across space, but instead form a complex interconnected web. Galaxies appear to be grouped in clusters and superclusters, forming long thread-like structures stretching across vast distances. These cosmic structures are not the result of random forces, but rather of the gravitational pull of matter, both visible and invisible. This discovery led to further research into dark matter, which was thought to account for the unseen gravitational forces that hold these structures together. Although dark matter could not be directly observed, its influence was evident in the way galaxies and galaxy clusters interacted. The discovery that galaxies form a cosmic web not only changed the way scientists view the structure of the universe, but also opened up new avenues of research into the role of dark matter and dark energy in shaping the cosmos. Another crucial piece of information that the Hubble Deep Field revealed was the sheer number of galaxies that populate the universe. It showed in no uncertain terms that the universe is far more expansive than anyone had previously imagined. The fact that so many galaxies existed in such a small patch of sky suggested that galaxies were far more abundant than once thought. This discovery emphasized the vastness of space and the complexity of the universe. The Hubble Deep Field brought into focus the immense scale of the cosmos, challenging the idea that we could ever fully comprehend it. What we see through Hubble's lens is only a fraction of the universe's true scale. Each galaxy is home to billions of stars, and within those stars countless planets and moons, perhaps many of which harbour life. This realization led to the understanding that the universe is not just vast in terms of distance, but also in terms of the number of objects it contains. The Hubble Deep Field also allowed scientists to make significant strides in our understanding of the rate at which the universe is expanding. By measuring the redshift of the galaxies in the image, astronomers were able to determine how far away each galaxy was, and in doing so they could calculate the rate at which the universe was stretching. This measurement was crucial in refining the model of cosmic expansion that had been proposed earlier in the century. The concept of an expanding universe, which had been first suggested by Edwin Hubble in the early 20th century, was now being confirmed by modern observations. The idea that the universe began as a single point in a hot, dense state and has been expanding ever since became more and more solidified with each new piece of evidence, such as the Hubble Deep Field. This evidence, in conjunction with other astronomical observations, helped lead to a more refined understanding of the Big Bang theory and the subsequent evolution of the universe. Looking back at the galaxies in the Hubble Deep Field also provided insight into the processes that govern the birth and death of stars. The image revealed that galaxies are not static entities, they evolve over time. Some of the galaxies observed were in the process of forming new stars, while others showed evidence of star formation that had already ceased. The observation of galaxies at different stages of their life cycles allowed astronomers to study the evolution of galaxies from their birth to their decline. The Hubble Deep Field demonstrated that galaxies, much like living organisms, have a lifespan, one in which they are born, evolve, and eventually fade away. This dynamic process, shaped by factors such as the availability of gas and the gravitational interactions between galaxies, plays a central role in determining the future of these galaxies. It's a reminder that the universe is not a static place, but one in which matter and energy are constantly in motion, changing and evolving. In addition to offering a view into the past, the Hubble Deep Field also gave us a glimpse of the universe's future. The galaxies captured in the image were observed at different points in time, and by studying their evolution, astronomers could learn about the future of galaxies like our own. What will happen to our galaxy, the Milky Way, in the coming billions of years? How will it interact with its neighbouring galaxies like the Andromeda Galaxy? The Hubble Deep Field suggested that, like other galaxies, the Milky Way will eventually collide with nearby galaxies, and this process will change its structure over time. Such interactions are a natural part of galaxy evolution. However, these events happen on such long timescales that they seem distant to us, yet they remind us that our universe is constantly evolving. The Hubble Deep Field also forced us to confront our place in the vastness of the cosmos. The image captured not just distant galaxies, but also our own insignificance in the grand scale of the universe. In the deep field, Earth is just a speck, a pale blue dot lost among billions of galaxies. This perspective has profound implications for our understanding of the cosmos. It highlights how small and fragile our world truly is, while at the same time it underscores the remarkable ability of human beings to explore and comprehend the universe. The Hubble Space Telescope, through its deep observations, has allowed us to peer into the vastness of space and time, giving us a unique perspective on our place in the universe. While the Hubble Deep Field revealed many remarkable things about the universe, it also raised new questions. How many more galaxies are out there waiting to be discovered? What other processes shape the evolution of galaxies and stars? What role do dark matter and dark energy play in the formation and behaviour of galaxies? These questions, still at the forefront of astronomical research, remind us that the universe remains full of mysteries. The Hubble Deep Field is just one step in humanity's ongoing quest to understand the cosmos, and it has paved the way for future discoveries. With each new observation, we get a little closer to understanding the universe's origins, its current state, and its ultimate fate. As the Hubble Space Telescope continued its mission, it became clear that the deep field image was only the beginning of a profound new era in space exploration. The image provided a snapshot of the universe at a time when galaxies were still in their infancy, helping scientists understand how galaxies evolve and interact over billions of years. In the years following the release of the Deep Field, astronomers began to use Hubble's capabilities to study even more distant galaxies, pushing the boundaries of what was previously thought possible. The original Hubble Deep Field image would be followed by deeper observations, eventually leading to the Hubble Ultra Deep Field in 2004, which pushed the limits of what Hubble could observe, capturing galaxies that existed more than 13 billion years ago. The additional deep field observations extended our view further into the past, revealing galaxies that were even younger, further back in time, and giving us a deeper understanding of the universe's formation. The Hubble Ultra Deep Field, taken from a region near the original Deep Field, provided even clearer insights into the evolution of galaxies. These galaxies, many of which were not visible in any previous images, were observed at various stages of development. Some were still in the process of forming, others had matured into established systems, and some had already ceased star formation. The image allowed astronomers to explore how galaxies evolve over time, from their early chaotic formations to their more stable, organized states. Through these images, scientists began to piece together how galaxies, and by extension the universe, matured, revealing that the universe's early years were far more active and dynamic than previously thought. What made these images so powerful was their ability to show galaxies that existed when the universe was a fraction of its current age. The galaxies captured in the Hubble Ultra Deep Field, for instance, were located in a region of space so distant that their light had taken billions of years to reach us. The Hubble Space Telescope, with its sharp resolution and wide field of view, allowed scientists to observe objects that were not only physically far away, but also existed in the distant past. This provided an invaluable window into the universe's history, showing galaxies as they appeared when the universe was only a few billion years old, an age that corresponds to roughly 1/5 of the current age of the universe. This allowed astronomers to study the earlier stages of galaxy formation and gain insights into how the building blocks of the universe were assembled over time. The continued exploration of the distant universe, facilitated by Hubble, led to important discoveries about the nature of galaxy formation. It became clear that galaxies did not form in a uniform manner as once assumed. Instead, galaxies developed in a variety of ways influenced by different factors such as their location in the cosmos, their interactions with other galaxies, and the amount of gas available for star formation. Some galaxies, for example, were observed to be merging while others were still in the process of forming stars. These mergers and interactions were seen as crucial in shaping the eventual structure of galaxies. Through Hubble's observations, scientists realized that galaxies are not fixed objects, but dynamic systems constantly evolving and changing over time. This shift in perspective was significant because it changed the way scientists thought about galaxy formation. The early theories which suggested that galaxies formed in isolation and evolved in a predictable manner were no longer sufficient to explain the diversity of galaxy types and behaviors observed in the deep field and ultra-deep field images. Instead, it became clear that galaxies were part of a much larger, more complex cosmic structure, one that was shaped by gravitational forces, cosmic collisions, and the constant flow of gas and energy. The early years of galaxy formation were chaotic, and the interactions between galaxies played a central role in shaping the universe we observe today. In addition to uncovering the complexity of galaxy formation, Hubble's deep field observations also provided valuable data about the structure of the universe itself. By studying the distribution of galaxies in the deep field, scientists gained insights into the large-scale structure of the cosmos. They discovered that galaxies were not scattered randomly throughout space, but instead formed clusters and superclusters interconnected by vast stretches of empty space. These cosmic structures are shaped by the forces of gravity, with galaxies bound together in vast webs of matter. The discovery of these large-scale structures helped scientists understand how matter in the universe is organized and how it evolved over time. Hubble's observations also led to breakthroughs in our understanding of the expansion of the universe. By measuring the redshift of light from distant galaxies, scientists were able to determine how far away each galaxy was and how quickly it was moving away from us. These measurements provided the first direct evidence of the universe's expansion, supporting the theory that the universe began as a hot, dense point and has been stretching outward ever since. The discovery of cosmic expansion also led to the realization that the universe's expansion is accelerating a phenomenon attributed to the mysterious force known as dark energy. The ability to measure the expansion of the universe using data from Hubble's deep field observations gave scientists a more precise understanding of the universe's age and size, and it laid the groundwork for future studies of dark energy. In addition to these significant scientific discoveries, the Hubble Deep Field had a profound impact on public understanding of the universe. The image of thousands of galaxies, some as far as 12 billion light-years away, captivated the public's imagination. It reminded us that we are not the centre of the universe, but rather just one tiny speck in an immense and largely unexplored cosmos. It also reminded us of the vastness of time and space. The light that reached Earth from those distant galaxies had travelled for billions of years, and in that time the universe had evolved in ways we're only just beginning to understand. The deep field image became a symbol of humanity's unyielding curiosity and our desire to explore the unknown. It demonstrated our ability to reach out across time and space, to peer into the distant past, and to uncover the secrets of the universe. The Hubble Deep Field and its follow-up images, such as the Hubble Ultra Deep Field, serve as powerful reminders of both our limitations and our potential. The universe is vast and much of it remains hidden from view. Yet through our exploration of space, we have made tremendous strides in uncovering the mysteries of the cosmos. As Hubble continues its mission, and as new technologies emerge to study the universe in even greater detail, we're only beginning to scratch the surface of what we can learn. The journey of discovery is ongoing, and the Hubble Space Telescope has played a central role in opening our eyes to the grandeur of the universe. The Hubble Space Telescope, with its remarkable ability to peer into the furthest reaches of space, continues to serve as a critical tool for understanding the universe. The image of the Hubble Deep Field and the subsequent observations of the Ultra Deep Field provided humanity with a new lens through which to view the cosmos. These images revealed a universe teeming with galaxies, each one a complex system of stars, gas dust, and dark matter. The discovery of so many galaxies, many of which were seen as they were billions of years ago, invited astronomers to reconsider their models of galaxy formation and evolution. The Hubble Deep Field did not just capture a still moment in time, it provided a snapshot of the cosmos in flux, a dynamic universe in constant change. One of the central revelations from these observations was the insight into the process of galaxy formation. The galaxies seen in the Hubble Deep Field were not like the ones we see in the nearby universe, mature, well-formed spirals or ellipticals. Instead, many of the galaxies in the deep field were still in the process of formation. Some were compact and irregular, showing evidence of rapid star formation in dense clumps of gas. Others appeared as elongated, asymmetrical shapes, revealing that they were not yet fully developed. This gave astronomers a glimpse into the early stages of galaxy evolution, when galaxies were still building their structures. These findings emphasize that galaxies do not form in a single uniform process. Instead, the formation of galaxies is a complex multi-step process that involves many factors such as the availability of gas for star formation, gravitational interactions, and mergers with other galaxies. The deep field images also revealed that galaxies were far more diverse in structure and behaviour than previously realised. Some galaxies appeared to be solitary, while others were part of clusters pulling matter together through the force of gravity. The Hubble observations suggested that galaxies are not static objects but dynamic systems evolving over time. This was a significant shift in thinking for astronomers, as it became clear that galaxies, like living organisms, go through life cycles from birth to death, from chaos to order. Some galaxies were observed to be in the process of merging with others, a process that is thought to play a crucial role in the evolution of galaxies. In fact, scientists now believe that galaxy mergers are a common event in the life of a galaxy, and that the Milky Way itself is on a collision course with the Andromeda Galaxy in the distant future. The diversity of galaxies seen in the Hubble Deep Field image was also a reminder of the vastness of space. The image, which captured a tiny sliver of sky, revealed thousands of galaxies, each one of them a miniature universe in its own right. It became evident that the universe was far larger and more complex than previously imagined. Each galaxy in the deep field represented an entire cosmos, with its own stars, planets, and potential for life. The image showed us that we are not just isolated in space, but a part of an interconnected web of galaxies, each one playing a role in the larger structure of the universe. The discovery that galaxies are not randomly scattered across space, but instead form large interconnected structures raised new questions about the nature of the universe itself. The Hubble Deep Field and its successor, the Hubble Ultra Deep Field, also allowed astronomers to begin unraveling the mysteries of dark matter and dark energy. These two substances, which together make up about 95% of the universe's total mass and energy, remain largely invisible to telescopes, yet their presence is felt through their gravitational effects. In the deep field images, astronomers could see the subtle effects of dark matter as it influenced the motion of galaxies within clusters. Dark matter acts as a cosmic scaffold holding galaxies and clusters of galaxies together, preventing them from flying apart due to the expansion of the universe. The study of dark matter remains one of the biggest challenges in modern cosmology, and Hubble's deep field observations continue to provide valuable clues that may one day lead to a breakthrough in our understanding of this mysterious force. While dark matter remains elusive, dark energy is even more enigmatic. It is thought to be responsible for the accelerated expansion of the universe, a discovery that was made just a few decades before the release of the Hubble Deep Field image. Dark energy exerts a repulsive force on the universe, pushing galaxies farther apart and causing the expansion of space to speed up. This discovery, made by studying the brightness of distant supernovae, was a profound shock to scientists, as it suggested that the universe was not just expanding, but expanding at an ever-increasing rate. The implications of this discovery are still being studied, but it has led to a new understanding of the fate of the universe. While the deep field image did not directly reveal dark energy, it provided important observational data that continue to help scientists refine their models of the universe's expansion and understand the role that dark energy plays in shaping its evolution. Beyond the insights into galaxy formation and dark matter, the Hubble Deep Field also served as a powerful reminder of the vastness of time. The light that reached the telescope from the distant galaxies had taken billions of years to travel across the universe. In some cases, the galaxies seen in the deep field were so far away that they existed when the universe was just a few 100 million years old. This means that the light we were seeing was not from the present, but from the past, a past that had been obscured from our view until Hubble's powerful instruments captured it. These distant galaxies represented the universe as it was long before the formation of our Sun and Earth. In a very real sense, the Hubble Deep Field allowed us to look back in time, offering a glimpse into the distant past when the universe was young and still evolving. The deep field observations also had a profound effect on our understanding of the universe's age. By measuring the redshift of the light from distant galaxies, scientists were able to estimate how far away these galaxies were, and in doing so determine the age of the universe. This was a critical piece of the puzzle in understanding the history of the cosmos. The Hubble Deep Field helped refine our estimate of the universe's age, which is currently thought to be around 13.8 billion years. This refinement of the universe's age is based on data from Hubble and other observatories, and it provides an important baseline for understanding the universe's development, from its origins in the Big Bang to its current state. Looking back at the universe's past through the lens of the Hubble Deep Field was not just an intellectual exercise, it was a chance to reflect on our place in the cosmos. The image showed us that the universe is vast, complex, and full of mysteries that remain to be explored. It reminded us that we are just one small part of a much larger interconnected system. The discovery of so many galaxies, each one with its own history and potential, challenged our preconceived notions about our place in the universe. In a sense, the Hubble Deep Field forced us to confront our own insignificance in the grand scheme of things, while also highlighting the remarkable nature of our existence. For the first time, we had a visual representation of the cosmos in its infancy, proof that the universe was a dynamic, evolving place, with billions of galaxy stars and untold possibilities waiting to be uncovered. The Hubble Space Telescope's observations of the distant universe, particularly through its deep field images, opened new avenues for understanding the fundamental processes that have shaped the cosmos. One of the most significant aspects of these images was the insight they provided into the ongoing mystery of galaxy evolution. For years, astronomers had speculated about how galaxies form and grow, but the deep field and its subsequent images offered the first clear, direct evidence of galaxy evolution in action. Hubble's sharp resolution and unprecedented ability to capture faint distant light allowed astronomers to study galaxies as they were billions of years ago, providing a snapshot of the universe's past that was previously out of reach. One of the most striking revelations from the deep field images was the diversity of galaxies even in the early universe. In the snapshot taken by Hubble, some galaxies appeared well-formed with spiral or elliptical shapes, similar to those we see today in the nearby universe. These galaxies were well along in their development, containing mature stars and well-defined structures. Yet in contrast, many other galaxies were still in the process of formation. They appeared as irregular, chaotic systems with no clear structure and evidence of ongoing star formation. These early-stage galaxies, often referred to as proto-galaxies, were in the process of merging or assembling their first stars. Some were small and compact, while others were larger, but lacked the organized structure of the galaxies we observe today. This diversity pointed to the complexity of the galaxy formation process, suggesting that galaxies do not follow a simple, predictable path as they develop. Instead, the formation of galaxies is a dynamic and chaotic process, influenced by a variety of factors such as the amount of gas available for star formation, the galaxy's environment and its interactions with neighbouring galaxies. These interactions, including mergers and gravitational influences, play a crucial role in shaping the evolution of galaxies. The Hubble Deep Field revealed that the universe's early years were marked by rapid growth, as galaxies collided, merged, and formed new stars. These observations confirmed that galaxy formation is not a static process, but one that is constantly evolving, with galaxies changing their shape and structure over time. In addition to providing evidence of galaxy formation, the Hubble Deep Field also allowed astronomers to study the conditions that led to the creation of the universe's first stars. These early stars, which formed out of the primordial hydrogen and helium that emerged from the Big Bang, were crucial in shaping the universe as we know it. The deep field images showed that star formation was an ongoing process in the early universe, with new stars being born in the centres of galaxies and in isolated gas clouds. However, star formation did not happen uniformly across the universe. In some regions, star formation was intense and widespread, while in others it was much slower and more sporadic. The rate at which stars formed varied depending on factors like the density of gas and the availability of heavy elements. As stars formed, they began to produce the elements that would later be incorporated into planets and life itself. The study of these early stars and their environments has been fundamental in understanding the chemical evolution of the universe. Stars are the factories where elements are created through nuclear fusion, and the heavy elements produced in the cores of stars are spread throughout the galaxy when the stars die. These elements, carbon, oxygen, iron, and others, are the building blocks for planets, and their formation is essential for the development of life. By observing the early stages of star formation in the Hubble Deep Field, astronomers have been able to piece together how the chemical composition of the universe evolved over time. In the early universe, only hydrogen and helium were present, but as stars formed, they began to create heavier elements. The process of stellar nucleosynthesis, which occurs in the cores of stars, led to the production of elements necessary for life, and this process continues today in the stars we see around us. The Hubble Deep Field also provided critical data for understanding the large-scale structure of the universe. By studying the distribution of galaxies in the image, astronomers were able to map out the cosmic web, an intricate network of galaxies, clusters and superclusters that stretch across the universe. The galaxies in the deep field were not scattered randomly, but instead were organized into vast interconnected structures, with large voids of empty space in between. These large-scale structures are thought to be shaped by the influence of dark matter, which exerts a gravitational pull on the galaxies. Dark matter, while invisible and not directly detectable, can be inferred through its gravitational effects on galaxies and galaxy clusters. The Deep Field image helps scientists refine their models of how these large-scale structures formed, providing valuable insights into the role of dark matter in shaping the universe. One of the key aspects of the universe's large-scale structure is the way galaxies are grouped together in clusters and superclusters. These structures are the result of gravity pulling galaxies toward one another over time. However, the Deep Field image also showed that galaxies do not just exist in clusters, but also in vast empty voids. These voids are regions of space that contain very few galaxies, and they make up about 80% of the universe's volume. The study of these voids is crucial for understanding the large-scale structure of the universe, as they represent the spaces between the cosmic web's filaments and clusters. By studying the distribution of galaxies in both clusters and voids, astronomers have been able to learn more about how the universe is organized and how it has evolved over time. The insights gained from the Hubble Deep Field have far-reaching implications for our understanding of the universe's origins and its future. By looking back in time, we can observe how galaxies formed, grew and evolved, shedding light on the processes that have shaped the cosmos. The image has provided critical data on the rate of star formation, the influence of dark matter, and the large-scale structure of the universe. These discoveries have helped astronomers refine their models of galaxy evolution and the history of the universe, bringing us closer to understanding the fundamental forces that govern the cosmos. Beyond the scientific discoveries, the Hubble Deep Field image has also had a profound cultural impact. It has inspired awe and wonder, reminding us of the vastness and complexity of the universe. It has opened our eyes to the fact that we are part of something much larger than ourselves, a vast cosmos filled with galaxy stars and mysteries yet to be unraveled. The image, once just a patch of dark sky, has become a symbol of human curiosity, ingenuity, and the pursuit of knowledge. The Hubble Space Telescope continues to push the boundaries of our understanding, and the discoveries made through its observations will shape our view of the universe for generations to come. As the Hubble Space Telescope continues to capture stunning images of the universe, the Hubble Deep Field remains a defining moment in the history of astronomy. The discovery of distant galaxies, many of which had never been observed before, expanded our view of the cosmos, revealing its true vastness. The Hubble Deep Field, which initially appeared to be a seemingly empty patch of sky, became a metaphor for how much of the universe was hidden from view, waiting to be uncovered. This observation, which seemed like an innocuous slice of space, transformed our understanding of the universe's depth, diversity, and complexity. For the first time, astronomers were able to see a vast number of galaxies stretching far back into the universe's history, some more than 12 billion years old. The light from these galaxies had travelled across unimaginable distances and time to reach Earth. In these galaxies, astronomers observed various stages of evolution, revealing the story of the universe's formative years. Through the Hubble Deep Field, astronomers were able to look into the very early stages of galaxy formation. The image showed galaxies at different points in their development. Some were in the process of merging, while others were still young, beginning to form stars. This confirmed that galaxy formation was not a uniform process. Instead, it was a dynamic and complex event. Some galaxies appeared to be far smaller and more chaotic, composed of less stable structures than the more familiar galaxies we observe nearby. These were not the typical mature galaxies such as our own Milky Way, but young galaxies still in the process of forming, revealing that the cosmos had undergone significant transformation since its early years. This was a critical observation, as it showed that the universe was not a static entity, but one that was constantly evolving. The galaxies of the early universe were vastly different from the ones we see today, and their interactions, mergers, and star formation processes would eventually lead to the galaxies we observe in the present. The Hubble Deep Field also provided crucial insights into the rate at which the universe was expanding. Through careful analysis of the redshift of light from distant galaxies, astronomers were able to calculate how fast these galaxies were moving away from us. which provided critical data on the expansion of space itself. The farther away a galaxy is, the faster it appears to be receding, a phenomenon known as redshift. This observation supported the theory that the universe had begun with the Big Bang and has been expanding ever since. The Hubble Deep Field confirmed the idea that the universe is still expanding, providing evidence of cosmic inflation and the accelerating expansion driven by dark energy. It also offered a rare glimpse into the universe's infancy, allowing scientists to measure how the cosmos had evolved from its early dense state to its current vast form. By revealing galaxies at various stages of evolution, the Hubble Deep Field also allowed scientists to begin making more accurate calculations of the universe's age. The galaxies observed in the deep field were so far away that their light had taken billions of years to reach Earth, meaning we were seeing them as they were in the distant past. By measuring the redshift of light from these galaxies, astronomers could estimate their distance, and consequently their age. This allowed them to refine their understanding of the age of the universe itself, which had been debated for centuries. Prior to the Hubble Deep Field, the age of the universe was still uncertain, but the observations made through the telescope's deep field images in combination with other measurements helped astronomers arrive at a more precise estimate, which is currently thought to be about 13.8 billion years. Beyond refining our understanding of the universe's age, the Hubble Deep Field also played a pivotal role in advancing the study of dark matter and dark energy. While these mysterious substances cannot be directly observed, their effects on the universe can be seen in the way galaxies move and interact. Dark matter, an invisible form of matter that does not emit light, exerts gravitational forces on galaxies, helping to hold them together. Similarly, dark energy, a mysterious force responsible for the accelerated expansion of the universe, is thought to be driving the universe's expansion at an increasing rate. The Hubble Deep Field provided critical data that allowed scientists to better understand the role of these invisible forces in shaping the cosmos. Through the deep field observations, astronomers were able to measure how galaxies were distributed across the universe, revealing the presence of large cosmic structures like galaxy clusters and superclusters, which were influenced by dark matter. These discoveries paved the way for future studies that have deepened our understanding of these elusive forces. The Hubble Deep Field image also had profound implications for the study of the possibility of life beyond Earth. By observing galaxies at various stages of development, astronomers could infer the conditions necessary for life to exist. The discovery of galaxies with signs of active star formation, as well as the identification of elements like carbon and oxygen, raised questions about whether similar processes could occur in our own galaxy, potentially leading to the formation of planets that could harbour life. The diversity of galaxies in the deep field also suggested that the conditions for life might be far more common than once thought. The study of these distant galaxies continues to offer important clues about the potential for life beyond our planet. While we have yet to find definitive evidence of life elsewhere in the universe, the Hubble Deep Field has provided critical data that suggests the universe is not only vast but teeming with potential for life. As astronomers continue to explore the universe using Hubble and other instruments, the insights gained from the Hubble Deep Field will continue to shape our understanding of the cosmos. The telescope's ability to observe distant galaxies and capture light that has travelled billions of years has forever changed the way we think about space. The discoveries made through the deep field have led to a deeper understanding of the universe's history, the forces that govern its evolution, and the conditions necessary for life. The Hubble Deep Field image serves as a reminder that the universe is not just a collection of stars and galaxies, but a complex and interconnected system filled with mysteries waiting to be unravelled. The more we learn about the cosmos, the more we realise how much there is still to discover. The Hubble Space Telescope has left an indelible mark on the field of astronomy, and its legacy will continue for many years to come. By unveiling the universe's past and revealing its complexity, the deep field images helped astronomers refine their models of galaxy formation, the expansion of the universe, and the nature of dark matter and dark energy. The Hubble Space Telescope opened a window into the distant past, showing us galaxies that existed billions of years ago and helping us understand how the universe has evolved over time. As new technologies and telescopes come online, the lessons learned from Hubble will continue to inform our understanding of the cosmos, and we will look back on the Hubble Deep Field as one of the pivotal moments in humanity's exploration of space. The revelations brought about by the Hubble Deep Field and subsequent deep field images continue to shape the course of modern cosmology. By providing a glimpse into the early universe, these observations prompted astronomers to reconsider the underlying principles governing the evolution of galaxies, the distribution of dark matter, and the ever-expanding nature of the universe. As scientists delved deeper into the mysteries unveiled by the Hubble Space Telescope, they found themselves grappling with new questions that extended beyond the initial excitement of discovery and sought to understand the very processes that governed the formation of galaxies, stars, and the elements themselves. One such discovery was the identification of galaxy clusters in the deep field observations. These clusters, vast groups of galaxies bound together by gravity, provided a deeper understanding of how galaxies interact on large scales. By studying these clusters, astronomers could measure the influence of dark matter, which cannot be observed directly, but makes its presence known through its gravitational effects on galaxies. In these dense clusters, the effects of dark matter were more pronounced as it helped to hold galaxies together, preventing them from scattering under the influence of the universe's expansion. The ability to observe the structure of galaxy clusters allowed scientists to gain a clearer picture of the distribution of dark matter throughout the universe. It confirmed that dark matter plays a key role in the formation of galaxies and clusters, acting as the unseen scaffolding that holds the visible universe together. The discovery of galaxy clusters also helped to refine our understanding of the rate of the universe's expansion. The Hubble Deep Field and its follow-up images provided new insights into the relationship between galaxies and the underlying cosmic expansion. By studying the distribution of galaxies and their motion, astronomers could measure the speed at which the universe was stretching. This provided vital data for understanding the rate of cosmic expansion and refining the cosmological models that describe the evolution of the universe. Over time, the study of galaxy clusters has provided valuable information about the universe's past, present, and future, offering clues about its ultimate fate and the forces that shape its continued expansion. In addition to studying the large-scale structure of the universe, the Hubble Deep Field and its successors also allowed astronomers to probe the life cycle of galaxies and stars. Through the images captured by Hubble, scientists could observe the different stages of galactic and stellar evolution, shedding light on the processes that lead to the birth, growth, and eventual death of galaxies. The Deep Field revealed galaxies at various stages of development, some in the process of forming new stars, others already well formed, and still others exhibiting signs of star formation that had long since ceased. These observations help to confirm that galaxies evolve over time, with their structures changing as they interact with other galaxies and undergo processes such as star formation, mergers, and the accumulation of matter. One of the most intriguing aspects of galaxy evolution is the role of star formation. The Hubble Deep Field showed that galaxies in the early universe were actively forming stars at a much higher rate than those in the present-day universe. In fact, the rate of star formation observed in the early galaxies was so intense that it led some scientists to speculate that the early universe was a much more violent and dynamic place than the relatively peaceful cosmos we see today. The intense star formation observed in distant galaxies suggests that the early universe was rich in the gas necessary for creating new stars, and that these stars formed in much greater numbers than in the present era. This intense star formation contributed to the rapid evolution of galaxies, shaping their structures and setting the stage for the formation of more mature galaxies like our Milky Way. At the same time, the Hubble Deep Field also revealed the consequences of star formation. In some galaxies, intense star formation was accompanied by supernova explosions that marked the death of massive stars. These supernovae not only enriched the surrounding gas with heavier elements, but also played a significant role in regulating the rate of star formation within galaxies. As massive stars exploded, they released vast amounts of energy, triggering shock waves that could compress gas and spark the formation of new stars. However, these explosions could also disrupt existing star-forming regions, halting the process of star formation for periods of time. In this way, the life cycle of stars and galaxies is intertwined with the birth and death of stars, influencing the evolution of galaxies on both large and small scales. The data from the Hubble Deep Field also provided valuable insights into the formation of supermassive black holes, one of the most mysterious and powerful objects in the universe. Observations from Hubble and other telescopes revealed that nearly every large galaxy in the universe contains a supermassive black hole at its centre. These black holes can contain millions or even billions of times the mass of our Sun, and they play a crucial role in the formation and evolution of galaxies. The deep field images reveal that supermassive black holes were present in the early universe, challenging previous theories about their formation. The discovery that these massive objects existed when the universe was still young raised new questions about the processes that allowed such enormous black holes to form in such a short amount of time. The presence of supermassive black holes in the early universe also provided new clues about the relationship between galaxies and their central black holes. Astronomers have long suspected that supermassive black holes and their host galaxies evolved together, with the black hole's growth influencing the formation of stars and galaxies. The Hubble Deep Field and other deep observations helped to confirm this relationship, showing that the formation of supermassive black holes was closely linked to the growth of galaxies. These findings have led to new theories about the role of black holes in the formation and evolution of galaxies, and how the presence of a black hole at a galaxy's centre can shape its future. In addition to shedding light on the mechanics of galaxy evolution, the Hubble Deep Field and other deep observations have also provided valuable data for understanding the nature of dark energy. This mysterious force, which is thought to be responsible for the accelerated expansion of the universe, was first detected through the observation of distant supernovae in the late 1990s. The discovery that dark energy exists was a profound shock to the scientific community, as it suggested that the universe's expansion was not slowing down as had been previously assumed, but speeding up. The data gathered from the Hubble Deep Field has helped to refine our understanding of dark energy, offering new insights into how this force operates and how it has influenced the universe's evolution. While much remains unknown about dark energy, the discoveries made through the study of the Hubble Deep Field have provided a foundation for future research into this enigmatic force. In many ways, the Hubble Deep Field serves as a testament to the power of human curiosity and the quest for knowledge. The image, which initially appeared to be a small empty patch of sky, turned out to be one of the most important astronomical discoveries of the 20th century. It revealed not only the vastness of the universe, but also the complexity of its evolution. Through the study of distant galaxies, stars, and cosmic structures, astronomers have been able to piece together the story of the universe's formation from its earliest moments to its current state. The Hubble Deep Field was the beginning of this journey, a journey that continues to unfold as we look deeper into the cosmos, searching for answers to the fundamental questions about the nature of space-time and our place in the universe. The Hubble Deep Field and its successors have not only provided significant insights into galaxy formation and the history of the universe, but have also paved the way for future astronomical discoveries. As new technologies and instruments emerge, the legacy of Hubble's observations continues to influence modern astronomy. Hubble's ability to observe distant galaxies, measure the distribution of dark matter, and refine the understanding of the universe's expansion has laid a foundation for future space missions and observatories. For example, the James Webb Space Telescope set to succeed, Hubble builds upon many of Hubble's discoveries and technological advancements, with the promise of observing even deeper into the universe's past and providing more detailed information about the formation of galaxies, the birth of stars, and the potential for life beyond Earth. One of the major implications of the Hubble Deep Field and its follow-up images is the refinement of the age and structure of the universe. By studying the light from distant galaxies, astronomers have been able to make significant strides in estimating the age of the cosmos. The deep field observations helped clarify the timeline of galaxy formation as they revealed galaxies in various stages of development, allowing astronomers to estimate how long it took for galaxies to evolve from chaotic formations into the mature, well-organized systems we see today. Hubble's contribution to cosmology has been monumental, as it provided crucial data for refining the Hubble constant, which is the rate of the universe's expansion. By measuring the redshift of light from distant galaxies, astronomers were able to develop a more accurate model of how the universe has expanded since the Big Bang. The Hubble Deep Field and its subsequent images also helped solidify the current understanding of dark matter and dark energy. For decades, scientists had theorized the existence of dark matter, a mysterious invisible substance that exerts a gravitational influence on galaxies but does not emit light. Hubble's observations of galaxy clusters provided some of the strongest evidence for dark matter, showing that galaxies and galaxy clusters are held together by this unseen force. Hubble's deep field observations also contributed to the discovery of dark energy, a force that accelerates the expansion of the universe. This unexpected discovery has fundamentally altered our understanding of the cosmos, as it suggests that a majority of the universe's energy is made up of substances that remain invisible to us. Dark energy in particular continues to be one of the greatest mysteries in modern cosmology. The observations made by Hubble, coupled with other studies such as the measurement of supernovae, revealed that the expansion of the universe is not slowing down as once believed, but accelerating. This has led scientists to propose the existence of dark energy, a force that works against gravity and pushes galaxies farther apart. Despite its pervasive influence, dark energy remains a largely unexplained phenomenon. Hubble's data, however, has provided critical clues that continue to guide cosmologists in their efforts to understand this force. As scientists work to uncover the nature of dark energy, they are relying on Hubble's deep field data to refine their models and explore how dark energy has shaped the evolution of the universe. Another major discovery prompted by the Hubble Deep Field is the role of galaxy mergers in the cosmic evolution. When studying distant galaxies, Hubble observed that many were not isolated systems, but were instead interacting or merging with neighbouring galaxies. This finding was significant as it suggested that galaxies do not evolve in isolation, but rather are often shaped by their interactions with other galaxies. The merging of galaxies is a common event in the universe, and these interactions can have profound effects on the structure and star formation within the galaxies. For example, when two galaxies collide, their gas clouds can compress, triggering bursts of star formation. These mergers also play a crucial role in the growth of supermassive black holes at the centers of galaxies. By studying galaxy mergers in the deep field images, astronomers were able to develop a more complete picture of how galaxies evolve over time, with mergers playing a key role in their development. The Hubble Deep Field also provided critical data for studying the universe's larger scale structure. Before the advent of deep field observations, astronomers had a limited understanding of the distribution of galaxies across the cosmos. The deep field images revealed the complex web-like structure of the universe, showing how galaxies are not distributed evenly, but instead form large clusters connected by vast stretches of empty space. This cosmic web, with its clusters and superclusters of galaxies, is influenced by the gravitational pull of dark matter, which acts as the invisible glue that holds these structures together. The study of these large-scale structures has provided crucial insights into the role of gravity and dark matter in the formation and evolution of the universe. It has also led to a deeper understanding of how galaxies and clusters of galaxies interact with one another, furthering the understanding of the forces at play in the cosmos. While the Hubble Space Telescope has been instrumental in expanding our understanding of the universe, the deep field images also highlighted the limitations of our current knowledge. Even as new discoveries continue to be made, the universe remains filled with mysteries that cannot yet be fully explained. For example, while dark matter and dark energy have been inferred through their effects on galaxies and galaxy clusters, their true nature remains elusive. The Hubble Deep Field provided the first evidence of these forces, but much work remains to be done in order to uncover their full characteristics. Similarly, while astronomers have gained insight into galaxy formation, Many questions remain about the exact processes that govern the birth and evolution of galaxies. The Hubble Deep Field images revealed the complexity of the universe, but they also showed that there is much more to learn. These uncertainties drive the ongoing exploration of space and the continued quest to answer some of the most fundamental questions in science. As the Hubble Space Telescope nears the end of its operational life, its legacy will continue to influence the field of astronomy. The data collected by Hubble will remain a key resource for future astronomers, offering invaluable insights into the history of the universe. In addition, the lessons learned from Hubble's mission will guide the development of new technologies and missions that will push the boundaries of space exploration even further. The Hubble Space Telescope's legacy is not just the discoveries it has already made, but the path it has paved for future generations of astronomers who will continue to look up at the stars seeking answers to the questions that remain. Ultimately, the Hubble Deep Field serves as a powerful reminder of both the vastness of the universe and the ingenuity of humanity. In one small patch of sky, Hubble revealed thousands of galaxies, each one with its own history and potential for discovery. The image encapsulated the essence of exploration, the desire to understand the unknown, to look beyond what is immediately visible, and to seek out the mysteries of the cosmos. Through the Hubble Space Telescope, humanity has made tremendous strides in understanding the universe, but the journey is far from over. As we continue to study the cosmos, we're reminded that there is always more to learn, and that the universe's vastness and complexity will always hold new mysteries waiting to be uncovered. The discoveries brought about by the Hubble Space Telescope, particularly those made from deep field observations, have had lasting impacts on the way astronomers study the universe. In particular, the data captured in these deep field images help to answer long-standing questions about the distribution and evolution of galaxies. However, these discoveries also sparked new questions, many of which have led to an even deeper examination of the universe. One such question centers on the role of dark matter and dark energy in shaping the cosmos. While dark matter has been detected indirectly through its gravitational effects on galaxies and galaxy clusters, it has yet to be directly observed. Dark energy, a mysterious force thought to be responsible for the accelerated expansion of the universe, presents even greater challenges as it remains invisible and has yet to be fully explained. Yet through the deep field images, Hubble has provided crucial observational data that have helped refine cosmological models of the universe. Dark matter, although invisible, has a profound impact on the universe's structure. In the Hubble Deep Field and other deep observations, scientists could see the effects of dark matter on galaxy clusters. These clusters, which are some of the largest structures in the universe, are held together by gravity. However, the amount of visible matter in these clusters is not enough to account for their observed gravitational pull. The extra gravitational force required to hold these massive clusters together must come from something unseen dark matter. Hubble's observations of galaxy clusters have provided key insights into the distribution of dark matter, showing that it is present in large amounts, influencing the formation and movement of galaxies. These findings have allowed scientists to map dark matter's presence across vast regions of space, giving them a clearer understanding of its role in the formation of galaxies and galaxy clusters. Dark energy, which is thought to drive the accelerated expansion of the universe, remains an even more perplexing mystery. The discovery of dark energy came as a result of observing distant supernovae, whose light revealed that the universe's expansion is not slowing down as once expected, but instead accelerating. This was a breakthrough discovery suggesting that something is causing galaxies to move apart at an ever-increasing rate. While scientists do not fully understand the nature of dark energy, its effects are undeniable. The Hubble Deep Field and other deep field observations have provided critical data that support the existence of dark energy, further refining our understanding of the universe's expansion. By observing the redshift of light from distant galaxies, astronomers can measure how quickly they are receding from us, helping to refine models of cosmic expansion and the role dark energy plays in this process. Beyond its contributions to the study of dark matter and dark energy, the Hubble Deep Field has also provided insights into the broader question of galaxy evolution. The vast array of galaxies seen in these deep field images has allowed scientists to study the processes that drive galaxy formation and growth. In particular, Hubble has shown that galaxies are not static objects, but are constantly changing over time. They evolve through a variety of processes, including mergers, interactions, and the accretion of gas. One of the most important discoveries made by Hubble is the role of galaxy mergers in the cosmic evolution. The Hubble Deep Field revealed that many of the galaxies observed were in the process of merging with other galaxies. These mergers, which are common events in the universe, play a central role in galaxy evolution. When two galaxies collide, their gas clouds are compressed, triggering bursts of star formation. These mergers also contribute to the growth of supermassive black holes at the centers of galaxies. The study of galaxy mergers has revealed that the growth and evolution of galaxies are intimately tied to their interactions with other galaxies. This means that galaxies are not isolated systems, but are part of a larger cosmic network constantly interacting and evolving. These interactions can have profound effects on a galaxy's structure and star formation activity. For example, when galaxies merge, their gravitational forces can cause their stars to be redistributed, leading to the formation of new structures. In some cases, galaxies can even be destroyed or absorbed into larger galaxies. The Hubble Deep Field provided the first direct evidence that such interactions were occurring in the early universe, confirming that galaxy mergers are a common and essential process in the evolution of the cosmos. Another significant discovery from the Hubble Deep Field is the role of star formation in galaxy evolution. The deep field images revealed that many of the galaxies observed were actively forming stars. This process, known as star formation, is one of the key drivers of galaxy evolution. Stars are born from clouds of gas and dust, and their formation is a complex process that depends on a variety of factors, such as the availability of gas, the presence of external forces like gravity, and the age of the galaxy. In the early universe, star formation was much more intense than it is today. Galaxies in the deep field were observed to be forming stars at a much higher rate than those in the nearby universe. This intense star formation was a hallmark of the early universe, when galaxies were still building their structures and fueling the growth of stars. The Hubble Deep Field also showed that the rate of star formation in galaxies is not constant but varies over time. In some galaxies, star formation was happening at an exceptionally high rate, leading to the rapid growth of new stars. In others, star formation had slowed or ceased altogether. This variation in star formation rates provided new insights into the processes that govern galaxy evolution. It suggested that galaxies go through different phases of star formation, driven by factors such as the amount of gas available and the gravitational interactions between galaxies. This dynamic process is responsible for shaping the structure and composition of galaxies over time. In addition to providing a better understanding of galaxy formation and evolution, the Hubble Deep Field also had profound implications for the search for life beyond Earth. As astronomers studied the distant galaxies in the deep field, they began to consider the possibility that the conditions for life might not be unique to Earth. The discovery of billions of galaxies, many of which contained stars similar to our Sun, led scientists to wonder whether there might be other planets in the universe capable of supporting life. The study of exoplanets, the planets that orbit stars other than the Sun, has been a key area of research in recent years, and Hubble's deep field observations have played an important role in this effort. By studying distant galaxies, astronomers have gained valuable insights into the conditions necessary for the formation of habitable planets, which could one day lead to the discovery of life beyond Earth. As Hubble continues its mission, the discoveries it has made will continue to shape our understanding of the universe. The Hubble Deep Field, with its unprecedented view of distant galaxies, has fundamentally changed the way we think about the cosmos. It has shown us that the universe is vast and dynamic, filled with galaxies, stars, and untold mysteries. It has revealed the intricate processes that govern galaxy formation and evolution, and it has opened up new avenues of research into the nature of dark matter, dark energy, and the potential for life beyond Earth. The Hubble Space Telescope, through its deep field observations, has given us a window into the past and a glimpse of the future, helping to answer questions that have fascinated humanity for centuries and inspiring future generations to continue exploring the cosmos. The vastness and complexity of the universe as revealed through the Hubble Space Telescope's deep field observations have made it clear that we are only beginning to understand the true nature of the cosmos. Each discovery from the telescope has expanded the boundaries of what we know, whether it's the diversity of galaxies, the role of dark matter, or the vast distances that separate us from the earliest moments of cosmic history. The Hubble Deep Field images, which provided an unprecedented view into the distant universe, highlighted how much we have yet to learn, while also showing how far we have come in our exploration of space. One of the most profound aspects of the Hubble mission is the way it has connected our understanding of the universe's distant past with the present, allowing us to trace the evolution of galaxies from their beginnings to the present day. In many ways, the Hubble Deep Field and its successors serve as a mirror reflecting the process of scientific discovery itself. They show the evolution of knowledge from the early questions about the formation of galaxies to the more refined models of cosmic expansion and dark matter. The images captured by Hubble tell a story of growth of understanding pieced together over time and the work of generations of scientists. Each new observation deepens our understanding, providing clues to questions that have existed for millennia. As new technologies emerge and our telescopes advance, the discoveries made by Hubble will remain foundational, continuing to inform the study of galaxies, stars, and the overall structure of the universe. One of the most significant aspects of the Hubble Deep Field images is the way they have informed the study of cosmic distances. The light from the galaxies captured in these images had travelled billions of years to reach Earth, allowing scientists to measure the vast distances between galaxies and better understand the size of the universe. The concept of distance in the universe is not just a matter of space, but also time. The farther away a galaxy is, the older the light we observe. This gives us a snapshot of how the universe looked in the past, providing valuable information about its evolution. Measuring cosmic distances with such precision has had a profound effect on how astronomers think about the universe's expansion and its age. The discovery that the universe is expanding first, proposed in the early 20th century and later confirmed by Hubble's observations, has also led to a deeper understanding of the universe's fate. The measurement of redshift in the light from distant galaxies, which shows how far they have moved away from us, provided evidence that the universe has been stretching since the Big Bang. In combination with the discovery of dark energy, which accelerates the expansion of the universe, these observations have contributed to the realization that the universe is not only growing, but doing so at an increasing rate. This has important implications for our understanding of the future of the cosmos. As galaxies move farther apart, the universe will continue to expand and its rate of expansion will increase, leading to a future where galaxies are even more isolated from one another than they are today. The discovery of dark energy and dark matter, though still not fully understood, has had a profound impact on modern cosmology. The Hubble Deep Field helped astronomers observe how galaxies and clusters of galaxies were distributed across the universe, revealing the presence of invisible matter that affects the way galaxies move. Dark matter, which does not emit or absorb light, cannot be seen directly, but its gravitational effects on galaxies and galaxy clusters are unmistakable. By mapping out the distribution of galaxies in the deep field, astronomers could infer the presence of dark matter and begin to understand its role in the formation of galaxies and the overall structure of the universe. Dark energy, meanwhile, was first discovered through the observation of distant supernovae, which showed that the universe's expansion was accelerating. The study of dark energy, which makes up most of the universe's mass energy content, is still ongoing, but its discovery has fundamentally changed our view of the cosmos. The Hubble Space Telescope has also played an important role in the search for exoplanets, planets orbiting stars outside our solar system. In the years following the release of the Hubble Deep Field images, astronomers began using the telescope to study distant stars and search for planets orbiting them. While Hubble's primary mission was to study galaxies, stars, and nebulae, it has also contributed significantly to the field of exoplanet discovery. By observing the light from distant stars, Hubble has helped identify exoplanets and study their atmospheres, composition, and potential for habitability. This has led to groundbreaking discoveries, including the detection of exoplanets in the habitable zone, the region around a star where liquid water could potentially exist. These findings are critical for the search for life beyond Earth and have opened up new possibilities for understanding the conditions that support life on other planets. As Hubble's mission continues, its legacy grows stronger, and the discoveries made through its observations remain integral to the field of astronomy. Hubble has not only expanded our understanding of the universe's past, but has also provided the tools for future discoveries. The Hubble Deep Field and the knowledge gained from it have influenced subsequent space missions and the development of new telescopes. The discoveries made by Hubble have inspired scientists to ask new questions and to look deeper into the universe than ever before. Each new generation of astronomers building on the discoveries of the past pushes the boundaries of what is known, exploring the mysteries of the cosmos with the help of the tools and data that Hubble provided. While Hubble has provided remarkable insights into the universe, it also serves as a reminder of how much there is still to learn. For all the discoveries made, the universe remains filled with unanswered questions. How do galaxies continue to evolve? What is the true nature of dark matter and dark energy? Are there other habitable planets in the universe? These questions and many more continue to drive scientific inquiry. Hubble's legacy is not just in the discoveries it has made, but in the curiosity and exploration it has inspired. The telescope's ability to look deep into the past, its vision of galaxies that existed billions of years ago, has reshaped the way we think about the cosmos and our place in it. It reminds us that the universe is not only vast and complex, but that it is full of mysteries waiting to be unravelled. The Hubble Space Telescope's contributions to the field of astronomy have only just begun to bear fruit, and as technology advances, the search for answers will continue. The Hubble Deep Field in particular stands as a testament to the power of scientific inquiry. It began with a simple observation of a seemingly empty patch of sky, yet it transformed our understanding of the universe. From that single, seemingly insignificant patch, Hubble revealed the intricate web of galaxies stretching across time and space. It is a profound reminder that even in the quietest and most seemingly empty corners of the universe, there is much to discover. As Hubble's mission has unfolded over the years, its impact on the field of astronomy has been profound, providing critical data that has reshaped our understanding of the universe. Each observation made by Hubble, whether it's a snapshot of a galaxy billions of light years away, or the precise measurement of the distribution of dark matter, has added another layer to the intricate tapestry of cosmic knowledge. But perhaps one of the most significant contributions of the Hubble Space Telescope is its role in shifting the perspective of the entire scientific community. Before Hubble, astronomers had limited views of the cosmos, either through ground-based telescopes or from observations within our relatively small region of space. Hubble, however, opened up a new frontier by offering an unobstructed, high-resolution view of the universe beyond Earth's atmosphere. This radical shift in perspective allowed scientists to observe phenomena that had previously been hidden or misunderstood, from the earliest galaxies to distant supernovae and black holes. The Hubble Deep Field, one of the telescope's most iconic images, represents a milestone in this transformative journey. By focusing on a small, seemingly empty patch of sky, Hubble provided an unprecedented glimpse into the distant universe, revealing thousands of galaxies, some of which had never been seen before. This image not only changed the way scientists viewed the cosmos, but also gave rise to a more fundamental understanding of our place within it. The light from these galaxies had taken billions of years to reach Earth, and in that time the universe had undergone countless changes. As the Hubble Deep Field allowed us to peer back in time, it reinforced the idea that the universe is constantly evolving, that galaxies are not static but undergo significant transformations over billions of years. One of the key insights gained from the Deep Field and subsequent Deep Field observations is the realization that galaxy formation is far more complex than initially imagined. Early theories suggested that galaxies formed in a relatively uniform manner, but the Hubble observations painted a more nuanced picture. The deep field images revealed galaxies in various stages of development. Some were in the process of forming, others were still chaotic and irregular, and some were well on their way to becoming mature structures. This observation suggested that the process of galaxy formation is not a linear progression, but rather one marked by constant interaction change and sometimes chaos. These interactions between galaxies, whether through mergers, gravitational interactions, or other cosmic forces, play a crucial role in the evolution of galaxies, leading to the diversity of galactic structures observed today. The Hubble Deep Field images also highlighted another fundamental aspect of the universe: its vast scale. Before Hubble, the universe was often thought to be far smaller than it actually is. But the deep field images, which captured galaxies spread across a seemingly infinite expanse of space, made it clear that the universe is far larger and more complex than previously imagined. The image captured thousands of galaxies, each one a miniature universe in its own right, and each one likely containing billions of stars, planets, and other objects. In this sense, the deep field not only provided a snapshot of the distant past, but also offered a glimpse into the mind-boggling scale of the cosmos. It is a reminder that Earth and even our entire galaxy is just one small part of a much larger cosmic structure, a structure that continues to expand and evolve with each passing moment. The vastness of the universe is also reflected in the sheer number of galaxies that Hubble has observed over the years. With each new deep field observation, astronomers have uncovered more and more galaxies, revealing a universe far richer in structure and diversity than anyone could have imagined. Each galaxy with its stars, planets, and dark matter is a unique system, but at the same time, all galaxies are connected within a broader cosmic web. The discovery of this vast interconnected network of galaxies, clusters, and superclusters has provided scientists with a more detailed understanding of how the universe is organized on the larger scales. By observing the distribution of galaxies, astronomers have been able to learn more about the forces that shape the universe's large-scale structure, particularly the influence of dark matter and dark energy. These discoveries have led to new theories about the formation and evolution of the universe, further refining our understanding of how galaxies came to be and how the universe continues to evolve. The Hubble Space Telescope has also made significant contributions to the study of supernovae explosions that occur when stars reach the end of their life cycles. By observing distant supernovae, Hubble has provided invaluable data about the processes that govern stellar death and the creation of heavy elements. Supernovae are one of the key sources of the heavier elements that make up planets, including Earth, and their study has helped astronomers understand how the elements we rely on for life were created. The data from Hubble has also provided insights into the distance and age of these supernovae, further refining our understanding of the age of the universe. These insights into stellar evolution have also shed light on the processes that shape the formation of galaxies, as supernovae play a critical role in regulating the rate of star formation within galaxies. One of the more profound contributions of Hubble has been its ability to detect distant supermassive black holes. These enigmatic objects, which are found at the centers of most large galaxies, including our own, play a central role in shaping the galaxies around them. Hubble's observations of distant galaxies revealed that supermassive black holes were already in existence when the universe was still very young. This raised important questions about how such enormous black holes could have formed so quickly. The study of these black holes has led to new theories about their role in the formation and evolution of galaxies, suggesting that the growth of supermassive black holes may be intimately linked to the growth of galaxies themselves. This discovery has prompted further research into the mechanisms behind black hole formation and the influence of these massive objects on the galaxies that host them. While Hubble's discoveries have reshaped our understanding of the universe, they have also raised new questions about the fundamental nature of space-time and matter. Even as we learn more about the universe, we are constantly reminded of how much remains unknown. One of the biggest mysteries is the nature of dark energy, which remains one of the most profound questions in modern cosmology. While scientists have gathered substantial evidence for its existence, much about dark energy's properties remains a mystery. Its role in the accelerating expansion of the universe is undeniable, but its underlying cause is still not fully understood. The continued study of dark energy, along with the ongoing exploration of dark matter, will likely remain a central focus of astrophysical research for years to come. The Hubble Space Telescope, with its unprecedented ability to look deep into the universe, has revolutionized our understanding of the cosmos. The Hubble Deep Field in particular has provided us with a glimpse of the universe as it was billions of years ago, offering insight into the formation and evolution of galaxies. As Hubble continues to capture new images and collect data, it will undoubtedly continue to inform our understanding of the universe, leading to new discoveries and refining our understanding of the cosmos. In the future, new technologies will allow us to look even deeper into the universe, uncovering more secrets about the distant past and offering new clues about the universe's origins and ultimate fate. The legacy of Hubble is more than just the discoveries it has made, it is the way it has transformed our understanding of the universe. The telescope has opened our eyes to the vastness of space, the complexity of galaxy formation, and the role of unseen forces like dark matter and dark energy in shaping the cosmos. Its contributions will continue to guide the exploration of space for years to come, inspiring future generations to look beyond the stars and seek out the mysteries of the universe. The impact of the Hubble Space Telescope on our understanding of the universe continues to resonate across the field of astronomy. As we reflect on the discoveries made over the past few decades, it is clear that Hubble's contributions have been nothing short of transformative. Not only has it revolutionized our understanding of galaxy formation, dark matter, and the cosmic web, but it has also reshaped the way we think about our place in the cosmos. The Hubble Deep Field, perhaps the most iconic image ever captured by the telescope, remains a key moment in this journey of discovery. It captured a seemingly empty patch of sky, and in doing so revealed thousands of galaxies, each one a glimpse into the distant past, showing us the universe as it was billions of years ago. These observations have shaped our understanding of the universe's evolution, showing how galaxies have formed, interacted, and evolved over time. One of the most profound impacts of the Hubble Deep Field was its ability to show us the universe as it was in its early years. The light from the galaxies captured in the image had travelled for billions of years to reach Earth, allowing us to observe these galaxies as they appeared when the universe was still young. The galaxies in the deep field were not the same as the galaxies we observe today. They were smaller, irregularly shaped, and actively forming stars, indicating that the universe was far more chaotic and dynamic in its early years than it is now. These early galaxies were in the process of forming, growing, and merging, contributing to the rich diversity of galaxies we see today. By looking back at these galaxies, we were able to gain insight into the processes that led to the formation of the more structured galaxies we observe now, such as the Milky Way. The Hubble Deep Field also provided a glimpse into the large-scale structure of the universe, revealing that galaxies are not scattered randomly throughout space, but are organized into vast interconnected structures. These structures, known as the cosmic web, are made up of galaxy clusters and superclusters, which are connected by vast stretches of empty space. The discovery of this cosmic web was a key finding, as it showed that galaxies are not isolated, but are part of a much larger interconnected network. These structures are shaped by the gravitational influence of dark matter, an invisible substance that makes up most of the universe's mass. The discovery of the cosmic web helped astronomers refine their models of how galaxies are distributed across the universe and how they interact with one another. It also highlighted the role of dark matter in shaping the universe's structure, providing further evidence for the existence of this mysterious substance. The study of galaxy clusters, a crucial element of the cosmic web, has been one of the most important contributions of Hubble's deep field observations. By studying these clusters, astronomers have been able to measure the distribution of dark matter and understand how it influences the formation and behavior of galaxies. Dark matter's gravitational effects on galaxies are critical in holding galaxy clusters together. Without dark matter, galaxies would not be able to form such large, massive structures. Hubble's observations of galaxy clusters have provided valuable data for understanding how dark matter interacts with visible matter, and has helped astronomers map its distribution across vast regions of space. This data is crucial for refining our models of galaxy formation, as it shows how galaxies are shaped by dark matter's influence, and how this substance has played a pivotal role in the evolution of the universe. As Hubble has continued to provide data on galaxy formation, star formation, and dark matter, it has also helped to refine our understanding of the universe's age. The light from the galaxies in the deep field has allowed astronomers to estimate the time it took for these galaxies to form, providing critical insight into the age of the universe. By measuring the redshift of the light from these galaxies, astronomers can determine how far away they are and calculate how long their light has taken to reach Earth. This has allowed scientists to estimate that the universe is about 13.8 billion years old, a significant refinement of previous estimates. The age of the universe is a fundamental parameter in cosmology, as it provides a baseline for understanding the timeline of cosmic events from the Big Bang to the present day. The Hubble Space Telescope's legacy extends beyond the deep field observations and the insights they have provided into galaxy formation and the large-scale structure of the universe. Hubble's data has also had a profound impact on the search for life beyond Earth. By observing distant galaxies and studying the conditions necessary for star and planet formation, Hubble has provided valuable information for understanding the potential for life elsewhere in the universe. The discovery of exoplanets, planets orbiting stars outside our solar system, has been one of the most significant developments in this field, and Hubble has played an important role in this discovery. The telescope has helped to identify exoplanets in the habitable zone, the region around a star where liquid water could exist, and study their atmospheres, providing crucial data for future missions to search for life beyond Earth. While the search for life beyond Earth is still in its early stages, Hubble's contributions have opened up new possibilities for understanding the conditions that make a planet habitable. The study of exoplanets combined with the data from Hubble's deep field observations has made it clear that the potential for life in the universe is far greater than previously thought. The discovery that there are billions of stars with planets in the habitable zone suggests that life may be more common than we ever imagined. This realization has profound implications for our understanding of the universe and our place within it, reminding us that we are not alone in the cosmos. As the Hubble Space Telescope continues its mission, its legacy will only grow stronger. With each new observation, Hubble adds to our growing understanding of the universe, helping to answer questions that have puzzled humanity for centuries. The data provided by Hubble will continue to inform future space missions, including the upcoming James Webb Space Telescope, which will build on Hubble's discoveries and take the search for knowledge even further. The Hubble Deep Field, with its breathtaking images of distant galaxies, will remain one of the most important milestones in the history of space exploration, representing the beginning of a new era in our understanding of the cosmos. The Hubble Space Telescope's discoveries have not only deepened our understanding of the universe, but have also inspired a new generation of scientists, astronomers, and explorers. The telescope's ability to capture stunning images of the cosmos, combined with its contributions to our understanding of dark matter, dark energy, and galaxy formation, has ignited curiosity and wonder. As we continue to explore the universe, the legacy of Hubble will guide our journey, offering us new insights into the vast interconnected cosmos and the fundamental processes that govern its existence. With each new discovery, we come closer to understanding the mysteries of the universe and our place in the vast expanse of space. The legacy of the Hubble Space Telescope is vast, shaping the landscape of modern astronomy and providing insights into the most fundamental aspects of the universe. Since its launch in 1990, Hubble has not only transformed our understanding of galaxies and cosmic structures, but has also inspired scientific curiosity and wonder across generations. Its deep field observations, including the iconic Hubble Deep Field, have provided unprecedented glimpses into the distant past, allowing astronomers to study galaxies that existed billions of years ago and offering a view of the universe at a time when it was still in its formative stages. These observations have revolutionized the way we think about the origins of galaxies, the structure of the cosmos, and the forces that drive the evolution of the universe. The Hubble Deep Field in particular holds a special place in this legacy. By focusing on a small, seemingly empty patch of sky, Hubble revealed thousands of distant galaxies, some of which were more than 12 billion light-years away. This image, which at first glance appeared to be just a quiet corner of the universe, proved to be a goldmine of information about the formation and distribution of galaxies, the early stages of cosmic evolution, and the processes that led to the development of the structures we see today. It was in many ways a turning point in our understanding of the universe. For the first time, we could observe galaxies in their infancy, offering a snapshot of the universe when it was only a fraction of its current age. The deep field observations that followed the initial Hubble Deep Field image have further expanded our understanding of the universe's vastness and complexity. Hubble's ability to observe galaxies at different stages of their evolution has provided crucial insights into the processes that govern galaxy formation. By observing these distant galaxies, scientists have been able to track their growth and evolution over time, shedding light on how galaxies come together, how they interact, and how they change in response to cosmic forces. The study of galaxy mergers, for example, has revealed the central role these events play in galaxy evolution, as galaxies collide, merge, and trigger the formation of new stars. These mergers, once thought to be rare and chaotic events, are now understood to be a common and essential part of the cosmic dance that shapes the universe. The discovery of galaxy clusters and the realization that galaxies are part of a larger cosmic web have also been instrumental in transforming our understanding of the universe's structure. The Hubble Deep Field helped to reveal the large-scale organization of galaxies, showing that they are not randomly distributed throughout space, but instead form intricate patterns of clusters and superclusters. These cosmic structures, held together by the gravitational pull of dark matter, form a vast network that spans the universe. This discovery has led to new insights into the role of dark matter in shaping the universe, and has provided valuable clues about how galaxies evolve and interact on cosmic scales. In addition to the revelations about galaxy formation and the structure of the universe, Hubble's observations have had a profound impact on our understanding of the forces that drive the universe's evolution. The discovery of dark energy, the mysterious force responsible for the accelerated expansion of the universe, has been one of the most significant breakthroughs in modern cosmology. Hubble's deep field observations, along with other observations of distant supernovae, provided the first evidence that the expansion of the universe is accelerating rather than slowing down. This discovery, which was a profound shock to the scientific community, has reshaped our understanding of the universe's fate. Dark energy is now thought to make up the majority of the universe's energy content, though its true nature remains one of the greatest mysteries in science. Alongside dark energy, dark matter has become another central focus of modern cosmology. Although invisible and detectable only through its gravitational effects, dark matter is thought to account for most of the mass in the universe. The discovery of dark matter was made possible by Hubble's observations of galaxy clusters, which revealed that the visible matter in galaxies is only a small fraction of their total mass. Dark matter plays a crucial role in the formation of galaxies and large-scale structures in the universe, providing the gravitational glue that holds galaxy clusters together. The continued study of dark matter, fueled by Hubble's observations, is a key area of research that will shape our understanding of the universe's composition and evolution. While dark matter and dark energy remain elusive, Hubble's data has provided essential clues that have helped to refine cosmological models of the universe. By observing the distribution of galaxies and galaxy clusters, measuring the redshift of light and tracking the movement of galaxies, Hubble has helped to improve our understanding of the rate of cosmic expansion, the nature of dark energy, and the role of dark matter in shaping the universe. The Hubble Deep Field in particular has played a pivotal role in this effort, providing astronomers with a detailed map of the distant universe that continues to inform our models of cosmic evolution. Hubble's contributions extend beyond the study of galaxies' dark matter and dark energy. The telescope has also played a central role in the search for life beyond Earth. The study of exoplanets, the planets that orbit stars outside our solar system, has been one of the most exciting areas of research in recent years. Hubble's observations have helped to identify exoplanets, measure their sizes and compositions, and study their atmospheres. By observing distant stars and looking for signs of planets orbiting them, Hubble has provided critical data for future missions to search for life beyond Earth. The discovery of exoplanets in the habitable zone regions around stars where liquid water could exist has brought us closer to answering the age-old question: are we alone in the universe? The Hubble Space Telescope, with its breathtaking images and groundbreaking discoveries, has deepened our understanding of the universe and transformed our view of the cosmos. It has opened up new avenues of exploration, revealing that the universe is far larger, more complex, and more dynamic than previously imagined. The Hubble Deep Field, a singular achievement in astronomical observation, has forever changed how we think about the cosmos. It has shown us that even in the emptiest-looking parts of the sky, there are countless galaxies waiting to be discovered, each one with its own story to tell. As we continue to explore the universe, the discoveries made by Hubble will serve as the foundation for future research, inspiring generations of scientists to look up and ask, what lies beyond? The legacy of Hubble is not just in the discoveries it has made, but in the questions it has raised, and the curiosity it has inspired. Its work has opened our eyes to the mysteries of the cosmos, showing us that the more we learn, the more we realize how much there is still to discover. The Hubble Space Telescope's mission is far from over, and as it continues to capture the beauty and complexity of the universe, it will undoubtedly leave an even deeper imprint on the field of astronomy. The discoveries made through Hubble's observations will continue to guide our understanding of the universe, reminding us of the endless possibilities that await as we look to the stars.